Hi everyone, we're Team 5. My name is Kalen Pexton, and these are my two teammates, Chris Hang and Chris Gudiel. And this is our critical design review for the Inogen Rove 6, a next generation portable oxygen concentrator. Our goal is to enhance patient mobility, energy efficiency, and ease of use for those requiring long-term oxygen therapy. In today's presentation, we'll walk through our design progress, review key challenges and changes, and show how our system is ready to enter our verification and validation phase. Next slide, please. At this stage, we have four major subsystems that are considered design ready. That's going to be the oxygen flow control, the power and energy management, the mechanical housing and chassis, and the user interface and control system. Each is supported by finalized CAD models, electrical schematics, firmware logic, and design documentation linked to our work breakdown structure tasks. The project is currently about 4 months behind schedule after resolving two major issues, a biocompatibility failure in our primary material and a compressor redesign, both of which have been successfully addressed. Despite the schedule shift, risk, cost, and quality metrics remain within control limits, and the system is ready for transition into the verification and validation phase. Next slide, please. So this diagram shows the complete system architecture for the Inogen Rove 6. Our design integrates 7 key subsystems working together to deliver safe and efficient oxygen therapy. These include oxygen generation and flow control, power and energy management, user interface and control, electronics and sensors, mechanical housing and structure, connectivity and communication, and manufacturing, quality, and support subsystems. Together, they manage oxygen delivery, power regulation, user interaction, and system data flow while maintaining manufacturability and regulatory compliance. By developing these modules in parallel and linking them through defined interfaces, we reduce the integration risks and ensured readiness for V&V once the new material passes biocompatibility testing. Next slide, please. So all of our design deliverables have been completed and mapped directly to their work breakdown structure tasks. These include CAD assemblies and DFM, DFA reports for the mechanical chassis, PCB layouts, and calibration data for our electronics, as well as UI mockups with human factors as test protocols. Each artifact is linked to its verification activity, ensuring there's full traceability from design to testing. And all documentation has been compiled into our device master record and device history file, meeting regulatory and quality system requirements as we move toward formal verification and validation. Next slide, please.
So our project has undergone two unforeseen events, that being the biocompatibility failure of the primary housing material and the oxygen compressor design failure. The cumulative schedule impact from both changes totals 8 weeks of controlled delay. The revised Gantt chart reflects this adjustment with rescheduled verification milestones. The earned value curve, the S curve in the bottom right, remains near baseline but extends upward by 60K due to extension of the critical path. The team's revised forecast projects completion of verification and validation by 4.5 months after the baseline. As such, the final deadline of the project has been extended by 4.5 months as the oxygen compressor issue does not affect overall project timeline. Despite moderate schedule and cost adjustments, the Inogen Rove 6 project remains on a stable and recoverable trajectory with slight increase in timeline. Design maturity is high, technical documentation is complete, and all key subsystems have achieved readiness criteria with verified mitigation actions and earned value trends improving. The project is positioned to finish the verification and validation phase 4.5 months after the baseline.
So starting with the first issue we faced, or the change request number one, would be the biocompatibility failure. More specifically, during verification, the device's primary material fails biocompatibility testing, showing unacceptable cytotoxicity levels. This just means that the original material cannot be used for clinical or regulatory testing. And one solution we implemented was using pre-qualified alternative materials. And how this impacts us is by delaying our schedule for around 4 months. Um, More specifically, or looking at the cost, it would be around 50K. Our graph below kind of sh shows that its cost curves, whereas the pink one shows the curve for our baseline, and the yellow line is the baseline with biocompatibility issue. Um, it shows a difference of roughly around 50K, and this all would be verified uh, with all the updates through QA or quality and assurance and regulatory affairs. Next slide, please. And following with the second issue would be the mechanism of the compression failure. So essentially, during the system level bench testing in the design phase, the compressor subsystem exhibited mechanical failure under extended operational loads. The compression mechanism linkage assembly experienced fatigue and partial fracture, resulting in insufficient pressure generation to sustain the required oxygen flow rate. So our solution was to redesign with improved geometry and materials. However, the impact on our schedule is negligible. However, there is a cost impact with roughly around 10,000, and that is shown with our graph shown below. Essentially, baseline two cost is the baseline with the biocompatibility issue shown in the first one, and the baseline three would be the baseline with both biocompatibility issue and oxygen compressor. And this essentially just shows us the difference of around 10K increase within the budget. And this is all done with the verification of no downstream impact and verified for durability and reliability. Next slide, please. So that just brings us to our updated risk register, in which the first one would be our material biocompatibility, which we showed earlier. And this one is resolved. And essentially, how we resolved it was by replacing non-compliant material with pre-qualified alternatives, which did pause our production build until retesting complete, which is resolved it right now. And the second one of our risk register would be the compressor reliability, in which essentially it replaces defective compressor with backup design, and it shifts production to alternative compression system, which issues repair kits for deployed units. And then our third one under the risk register would be prototype cost overruns. And essentially how we solve this is by relocating funds from later phases, such as marketing and training, which delay non-critical tasks, or we can seek additional budget approval if overruns persist. Next slide, please.
So during the course of project simulation, our team encountered a disruption event represented by the red 3 card, budget overrun during the prototyping phase. This event highlighted the risk of exceeding planned expenditures in early development due to the cost of rapid prototyping, testing iterations, and material adjustments. At the time, the King Black card emphasized the importance of maintaining consistency and quality in our process rather than compromising design rigor for short-term recovery. To address this disruption, we adjusted our time phase budget strategy by reallocating funds from later phases, such as marketing, material development, and training, to cover the prototyping overrun. This adjustment allowed the team to absorb the additional costs without jeopardizing core engineering and compliance activities. In short, we have adjusted WBS scheduling, revised budget, and added a new risk item to the risk register for budget overrun in prototyping. Currently, the project is in a relatively stable state. All major systems have reached design-ready status, and we've extended the overall timeline by approximately 4.5 months to accommodate the next phase of activities. In terms of budget, we're showing a total cost variance of about $60,000, which represents about 4% of the total budget. While this is a manageable deviation, we'll continue monitoring our spending closely as we enter verification and validation. Our next steps include completing the material re-verification, initiating V&V testing and documentation, and preparing the necessary materials for regulatory submission. Lastly, all relevant documentation and recording references can be found on the CDR cover page for review. Thank you.